We have the option here. So
Do you have an extra mask? I forgot one.
I do not have one,
Do I have to go back
unfortunately.
and get one? Or can I just?
I mean, I won't complain. It is the policy. So I don't know if any of your classmates will have an issue with it. So it's, I'm not going to kick you out,
Okay,
but
that's all I want to ask.
but if anyone has an issue that you might. Because
Does anyone care that I don't have a mask? Okay,
all right.
thank you.
Okay, dash now. All right, good afternoon, everyone. In 1 minute, I am trying to resolve this issue we had where I can't use the math libraries in JGrasp. I know this is what I've done before. I don't understand why it's not working. Let me just really quickly try to get that to work. And if I can't, we'll just ignore it and move on. Flags. Okay, let's just do that. All right. Oh, okay, very good. All right. All right, where were we? So recall that on Monday, we started on an exercise. We wrote our first slightly more complex computer program. Let's call it our second C program. Before we go back to that, I want to briefly finish the lecture. I said I would come back to it, and I wanted to talk about it today before we do, let's say, version 2 of that exercise. So if we go to functions, And here's what I want us to see. All right. So we've talked about functions. We understand that functions can return things. And we understand that input arguments or parameters are the mechanism that you use to pass information to functions. So let's talk a little bit about why we need that. There is something called scope. There is something called scope. And scoping rules, or scope in general, determines where in a file you have the ability to access particular variables. What do I mean by that? Let's quickly open this up. So we'll make some variables here, int A and B. So if I want to, anywhere below line 5 and above, let's just say line 12, I can reference those variables. I can use them. I have permission to do that. But this is the scope of these variables. This is the boundary within where they are accessible. I cannot access these variables outside of these brackets. Let's say we were to make another function. Make a simple one. What do we mean by that? I can't do this inside F, even if I call, obviously main will get called first, right? And let's say here, I call F1 like that. Even if I do that, and this has already been declared, it's outside of the scope of this function. This function doesn't have permission to see anything inside this set of brackets. And likewise, main does not have permission to see anything within these brackets. So this is an example of local scope. Local scope means variables can be used locally. They're visible locally. And this is really why we need things like parameters. If I need to pass this information, let's do this. We'll do that here. And let's say what I really want to do, I just want to print the value of A, right? This is what I want to do. What does this function do? It prints whatever A is. Well, I don't have access to A. I don't have permission to access A. So how do we get around that? All right, no problem. This is how we get around that. This is how we put information into the scope. Think about it that way, into the scope of F1. So imagine you have a box here and you have a box here, and they're separate boxes. You're not allowed to go from one box to another. You're only allowed to use what's inside this box. So if you need something, if you need to use something, you have to put it in the box. This is how you put it in the box, by passing it in as a parameter. And conversely, when the function exits and all this goes away, how do you get stuff out of the box? You get it out of the box like this, right? So when this function returns something, that's how you get stuff out of the box. That's how you get information from within this box into wherever it's going to be used. Right, so that's why these things are important. That's an example of local scope. Global scope, if I were to make something up here, it's typically frowned upon to do this, by the way. Sometimes you'll do it, but it's not considered secure programming to do this. When you declare a variable up here, it's visible everywhere. Anything that has access to this file can see that variable. We won't get into why it's not considered secure, but it is not considered a secure thing. But this is an example of a globally scoped variable. This variable has a global scope. Now, if I wanted to, I can do that. I do have permission to do that. I can modify X from here or in here. I do have permission to do that because the scoping rules for X are that anywhere this is visible, I'm allowed to use it. Local variables, that's not true. Now let's go over the brief example in the PowerPoint. So here we have these two functions. You have main, obviously, and you have this other one called input output, and it has one parameter. And what I want to try to do is pretend we're the computer and we're executing these instructions and kind of show the path that direction that information is flowing. So as we start, what is the first thing we do? Right now, main is the active function. So when you call another function, the current one is paused. We can think about it like that. It gets paused while the other function is running. And when the other function is done, we resume the previous one. So right now, main is the active function. And we're going to print f, and we're going to call this function here, input output 10. And what happens when we do this? Well, we're going to take the number 10, and we can imagine that we're passing the number 10 to this function. We're putting it in that box. All right, so this isn't active yet. It hasn't started executing yet. It's going to be soon. I'm going to be passing this number into that box there so that it can use it. And then I'm going to pause myself and wait for this function to return something. So right now, main is paused. It's just waiting for this function to finish executing. And this one too, but ignore that one for now. It's waiting for this one to finish executing. And this function is running right now. This is the active function. So only one function can be active at a time. For now, there are techniques to have multiple threads active, but we're not going to cover that in this class. So for this class, only one function can be active at a time. So this running, and what are we going to do? Well, I already know that you passed me the number 10, right? So I'm going to put it right here. So input 1 equals 10. I'm going to assign that value to my parameter, and then I'm going to use it here. I'm just going to add whatever you gave me. I'm going to add 2 to that, and I'm going to give it back. So what do we do? Once we hit this line right here, this return statement, what do? We take that number 12 and we pass it back to main. So we're going to take that 12 and we're going to pass that information back to main. So now main has it because main can't see in here and I can't see in there. Finally, this goes away. So once a function has finished executing, it doesn't exist anymore. This is one reason why you don't want to be able to access these local scopes of these individual functions, because once they stop running, they don't exist anymore. Those variables aren't there. So it's gone. We already passed the information to main, and now main can print out the number 12 because it received that information here, and that's how printf works. We're going to substitute that value for this format specifier here. All right, does that kind of make sense? So if you need information, you have to pass it to the function through parameters. If you need information back from the function, you get it from what the function returns. And that's necessary because we're restricted in what we're allowed to access. One function is not allowed to access the space of another function and vice versa. So with that, let's go back to our exercise. And what we're going to do today, we're going to modify this exercise. And if you didn't get it working, I'm going to do the first one here so you all can just split it up. We're going to take this first exercise and we're going to split it up, kind of, where instead of doing all of this in main, I want you to calculate this. So step 8 through 12, I want you to do that in a different function. All right, so you're going to ask the user for this information, get all the information you need, and then you're going to call your, calculate new hour function or whatever you want to call it, and it's going to do the math for you and print out the new time, whatever the new time would be. So let me see, I think I have this. Let me open it up here so I can have it side by side. In case some of us did not successfully complete the other exercise, let's go ahead and do this part together. And that's, here we go. And those of you that have JGrasp, feel free to use it. I would like you to. If you don't, sit with someone that does. So let's start by, we know we need to print stuff. So we need that library. For the time being, right, in the previous assignment, we did everything in main. So what do we want to do? Let's define some variables. So int, and I don't want to write those long names. So I'm going to write move hour, move minute, final minute. And later we're going to need to make this one. So let's go ahead and make current hour, current minute. So we have our variables now that we can use to store information. What do we need to do? Ask whoever is using the program, ourselves, what time it is. So let's just say, hey, what time is it? And we need to take that information and save it into our variable. So we're going to save it. Let's do this as a hint. Hour, minute. Right, so they know to pass it in as two separate values. And we'll do scanf, %d. So notice I did not write a new line here. So this is not the same as printf. Specifically, I'm looking for this information from the keyboard. If you put the new line, you're looking for a new line character for a keyboard. No, we're not. Right, we are looking for something from, you're going to type something to the keyboard, and I'm going to interpret it as that data type, a whole number. And we'll save it into current hour and current minute. Then what are we going to do? How far would you like to advance the clock? And we'll do the same thing here. Hint, hour, minute. And we'll do the same thing for move, right? So scanf, %d, and move hour and move minute. So now that we have all the information, last week what we did was we did steps 8 through 12 in main, right? We don't want to do, or 8 through 13. That's not what we want to do this week. But I'm going to do it here, and then you all can split it up. So let's take the final hour equals current hour plus move hour. I think that's what I called it, yes. And we'll do final minute equals current minute plus move minute. And we'll do, that one doesn't exist yet. Let's go ahead and make it. Minute carry. Minute carry equals final minute divided by 60. So we're doing integer division here. I don't want to do floating point division. I do want to discard everything that's not a whole number. And then we'll say final hour equals final hour plus minute carry mod 24. So we want to make sure that if you, let's say you want to advance 50 hours, there's no such thing as 51 o'clock. Right, so we're using 24-hour format here. So no matter how far you advance, once you pass 24, we'll go back around to 1, right? It'll just kind of like a clock does. How does it work? Recall we mentioned that modulo, that's what this % sign is. Modulo will divide one number by another, and it will give you back the remainder. So if it's 1 o'clock, and I want to advance 24 hours, it should still be 1 o'clock and not 25 o'clock. So if you do 1 plus 24, that's 25. If you divide it by 24, 24 goes into 25 one time. I'm sorry, yeah, one time, and it has a remainder of 1. Right, so we're going to throw away the first one, and we're only going to keep that one. Is still going to be 1 o'clock, right? So do it for 2 o'clock, same thing. 26, if you divide that by 24, it goes into 26 one time, and you have a remainder of 2. So what time is it? It's 2 o'clock. So if you advance 26 hours, it should be 2 o'clock. So where am I? Final hour, we'll take the final minute equals final minute, we'll do the same thing for minute. And then we're just gonna print it. Here is the new time. And we'll do hour, minute. And final hour, final minute. I suppose we should do time was, we'll just copy this. Okay, we'll do this. Time was, that was the time. Current hour, current minute. Moved forward this many hours and this many minutes. Move hour, move minute. And here's the new time. So if we compile this and run it, did I forget something? No. All right, if we compile this and run it, what should happen is it should ask me what time it is. So I'll say it's, let's do something easy, 3 o'clock. How far would you like to advance the clock? Let's just go forward 5 hours and see if it works. No minutes. So the new time is 8 o'clock. Very good. If we run it again, let's do something. Let's do something a little more challenging. Let's say it's 3 o'clock and I want to move forward 24 hours. Still 3 o'clock. Very good. We can run it one more time. What time is it? It's 3:50. And I want to advance 0 hours and let's just say 20 minutes. What time should it be? It should be 4:10. Very good. So this is how it's supposed to behave. Here's the code. And what I would like you all to do is figure out how to do this part of the algorithm in a function. I want this to be a function that you call. So for example, notice that right now, where did I start doing? I started doing that here on line 13, right? So this is step 8 through 13 of my algorithm. Instead of doing this, what I would like to be able to do is say, call time advance function here. This is where I would want to call that function. And that function should do all of this stuff instead of doing it in main. Does that make sense to everyone? All right, good luck. I'm here if you have questions. I'll leave. Do you want to see the algorithm or you want to leave this up? Which one do you want to see more? I can make one bigger than the other so it's easy to see. Oh, we'll leave them both up. Maybe it's useful to have the algorithm up too. We'll do like this.
Yes.
Awesome. That's a necessary part of the function definition. For sure, that's one. All right, let's see. Let's kind of give everyone a little bit of help for those of us that may still be struggling with this. So let's take a look at this piece here. We know we need to take these instructions and put them somewhere else. All right, so we're going to have to make a function. So let's think about that function we're going to make, how it should behave. We've got to define that function. So looking at these instructions here, if we, let's go back to our PowerPoint. Let's go to this slide right here. So looking at these instructions, we know that a function definition looks like this. This piece here is where we have to tell the computer what type of information that function returns. So if you look at these instructions, what kind of information do we think this function would return? Double? Well, let's see. See if I can Why would we need to return a double? Just curious. Why would you say that? I'm not saying you're wrong. I want us to think about
Well, actually, I now think that it,
what was that?
well, so doubles means decimal, right?
That's correct.
So then that means we don't need a double, so it should be like float.
A float is still a decimal.
And
An int. So why should we return an int? What's that?
Not like doing seconds, just the hours.
Okay. They're two separate variables, right? So should we return two things, two integers? Can we? How many things can a function return? One. Now later we'll learn how to do that, but right now we can't. We can only return one thing. So how do we get around that if we need to return an integer? Let's ask ourselves again, why do I need to return that integer? So we don't need to return anything. So let's move on to a different train of thought. Why do we think we need to return an integer? What's the goal? What are you going to do with that integer? I'm going to print it, right? I'm going to display it. Do I need to return something to execute this print command right here? I don't, right? This is what I want to do, but I'm supposed to do this in that function. So does my function need to return anything? No, because everything I need to do, I can do it right here. Main doesn't need any information from me when I'm done executing. I'm going to give you these values and you're going to print the time. That's all I want you to do. I don't need you to give me anything back. So we'll start there. We know this is going to be void. Now we don't have to define, I'm defining mine above main. You don't have to do that. One reason we might want to define it above main, remember that functions are like variables. The definition has to exist before you can use it. So you either define it before you use it, or you have to stub it, right? What do we call that stub? A function prototype. You have to make a function prototype. So we know the function is going to be void. What's the next part? If we look at here, what's the next necessary part of our function definition? A name. We have to call it something. It doesn't matter what you call it. We'll call it my time function. We'll just call it that. Now, the next important part of this function is right here between these parentheses. What is this for? What is this for? These are for our parameters, for information that we have to pass to the function. Does this function need any information in order to behave correctly? It does. What does it need to know? All the different times. Right. So how do I give that information to that function? So this function needs to print this stuff, but it can't do that calculation and print this stuff unless it knows all the information from main. Can I just do this? Let's say, what about this? Is this okay right here? What's wrong with that? That's right. It doesn't have permission to access those variables, does it? They're out of scope. So how do I give it those values? We know we have to do it through these parentheses. So how do I, in my function definition, how do I say, here are the values you need? Or here are some placeholders where you can give me values. How do we do that? That's right. We provide a comma separated list of variable declarations. So we need to declare some variables, and this is where we're going to put these values in. So looking at the code, let's undo this. Oh, no. Looking at the code, how many parameters do I need? Four parameters. So that's how many pieces of information do I need? What are they? What do I need? I need to know what? They're all ints. Huh? I need to know the current hour. I need to know the current minute. I need to know the move hour and the move minute. Now, unlike a regular variable declaration, you can't. So, normally we could do this, right? Int you know, variable one, variable three. You can't do that when you're defining a function, okay? You have to have 4 separate variable declarations. All right, so there's where we are right now. We've got our stub, our function stub. Now we just have to somehow transfer that logic from here to there. Well, let's do one more thing. Let's do one more thing. How do I call that function? So I've got my shell now. I have to still put the code in there, but I've got my shell. How do I call that function from here? Okay, we can type in the name, my time function. Is that it? Okay, we'll do the parentheses and the semicolon. Good to go now? How do I do that? That's right. So current hour, current minute, move hour, move minute. And it's just a coincidence that I named them the same thing. It's not important. These could have completely different names. They're 2 separate variables. All right, so this variables here and those up there are 2 different sets of variables. Very good. So that's how I would call it. Now the only thing remaining is to finish up that function.
We don't have it formatted so that it always comes to you. There's some special. So that comma was throwing off. Typically, the only thing you want to put in that block is format specified. When you put commas or maybe the other things, you're telling it, I'm expecting to see. So what I read in here, instead of saying, interpret that, maybe some of those characters. Remember, it's just one to read. Maybe something. I don't know, put the color, like, maybe some of those things, when they use it, have an X, have a number. All right, we are out of time. I would encourage you to continue to try to work on this. We do need to have a good understanding of functions. Everything you do in this class is going to depend on your understanding of functions and every topic we learn. But let me point out another resource for those of you that are having issues
getting JGraphs to run, if you just Google online compiler, online C compiler, there are tons of free online C compilers that you can use. Here's an example of one. And you can just, let's say, hit the run button. Now execute your code. So you could use this to practice, for example. So we can go here, include, math.h, and they even give you some form of IntelliSense. That's probably not as helpful as it could be, but printf 0.2lf how 1.2. Right, so we'll run this, and you can see you can run C code in here just like you can in Cygwin. So obviously it's more convenient to do it locally, and you can download it when you're done. You can make a new file, you can download the file. So there are other options. If you can't get Cygwin to work, you don't have to use JGraphs. You can go online and use one of these online editors that you don't have to set up. Right. If you all don't have any questions, have a good weekend, everyone. I'll see you next week.